Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the previous lecture we were learning the concept of counting rule, and we learned that counting rule is used to determine the total number of experimental outcomes of an experiment. And we put the few examples, and we were discussing this last example, call to 5 customers. So experiment is a call to the customer. Sales manager is calling to 5 customers. So experiment is what? Call to the customer. And how much step this experiment carry? 5 steps, 5 calls. And each call carry 2 outcomes. Customer will purchase the product or does not purchase the product. So, how to determine the total number of experimental outcomes of this experiment? We will use counting rule. What is counting rule? Simply multiply the outcomes of each step with each other and determine the total number of outcomes. So, in here, call to 5 customers, we have 5 calls. Total number of steps, total number of calls are how much? 5. Each call carry 2 outcomes. Customer will accept, purchase the product or does not purchase the product. These are the 2 outcomes of each call, each step, each trial. So how to calculate the total number of outcomes? I told you that we will simply multiply the outcomes of each call. So each call carry how much outcomes? 2. So we will multiply total number of outcomes is equal to the outcome of first call 2 multiplied by the outcome of second call 2 multiplied by the outcome of third call 2 multiplied by the outcome of fourth call and multiplied by the outcome of fifth call. How much calls we have? 5 calls, and we will multiply the outcomes of each call with each other. So we will determine the total number of outcomes, which is 32. So this is the counting rule to determine the number of experimental outcomes of an experiment before assigning probabilities to the outcomes. ما ای اگزامپل را دوباره در زبان دری میگم که اینجا سیلز منیجر که است و کال میکنه به 5 مشتری، به 5 مشتری و زنگ میزنه. چرا؟ مقصد ابجکتیو چی است؟ که باید پرودکت خود را میفروشه. خو اکسپریمنت پروسه میکنه، پروسه یا اکسپریمنت چی است؟ و زنگ میزنه به 5 customers. Ali ye experiment 5 steps dara, 5 calls us. और हर कॉल के अस वो 2 outcomes दara. या खो मुश्तरी प्रोडक्ट में खरा परचेज में कुना या इच ना में खरा, ये 2 outcomes हर कॉल दरा. खो आले सवाल यस कि मालूम को अंदाजा को कि ये एक्सपेरिमेंट के 5 कॉल्स द्वारा ये टोटल ची कदर एक्सपेरिमेंटल आउटकम्स द्वारा हो चतुर मुहासिबा मेशा टोटल नंबर ऑफ आउटकम्स चतुर कैलकुलेट मेशा बाय आउटकम हर कॉल के आस उकत खुद जरब शवा, यानी 5 कॉल्स 5 calls और हर कॉल 2 outcomes दर. खो आउटकम अवल कॉल 2 ज़रब आउटकम दोम कॉल 2 ज़रब आउटकम सियम कॉल 2 ज़रब आउटकम चारम कॉल 2 ज़रब आउटकम पंजम कॉल 2. बये फार्मूला टोटल या मजमुआ आउटकम ये एक्सपेरिमेंट की 5 calls द्वारा वो मुहासिबा में शा. इंजा टोटल नंबर ऑफ आउटकम्स 2 ज़रबे 2 ज़रबे 2 ज़रबे 2 बराबर बची बराबर टोटल आउटकम CO2 बराबर. ये काउंटिंग रूल है. काउंटिंग रूल मुहासिबा में कुना कि एक एक्सपेरिमेंट टोटल ची कदर आउटकम्स दा. काउंटिंग रूल फॉर कॉम्बिनेशंस. In this section, we will learn to determine the number of experimental outcomes of an experiment in the group of items form, in the combinations form. Like, for example, the outcomes of two items. Counting rule for combination means we are developing experimental outcomes of an experiment, but these outcomes are in combinations form, means in group of items form. In the group form, each outcome will carry more than one experimental outcomes or more than one possible items. I am again repeating, counting rule for combination mean we will learn how to determine the total experimental outcomes of an experiment, but in the group of items form. Each outcome will be in the group of items form. More than one outcomes will be included in one experimental outcome. That is why we call combination of outcomes. Means we will determine the small n number of outcomes from a large set of n objects. In this section, we will learn how to determine and how to list the experimental outcomes in combinations form, like the combinations of n experimental outcomes from the large set of total n number of experimental outcomes. So, again in here, objective is the same, that what are the total possible number of outcomes, but outcomes must be in group of items form, must be in combinations form. We will choose the subset n of items from the large set of n items. Let me read this theory. In this section, we will learn how to determine and how to list the experimental outcomes of an experiment in combinations form. Like what combination? Like the combinations of n. N is a subset. The combination of n experimental outcomes from the large set of total n number of experimental outcomes. We are determining the number of experimental outcomes in combinations form, which is a small n from the entire large set of data, which is n capital N. And what is the mathematical notation? This is the mathematical notation. C represent combination. This capital N represent the entire data, the entire objects, the entire total experimental outcomes of an experiment. This N, capital N, represent large data set of n objects, large data set of n number of outcomes, n represent total number of outcomes of an experiment, and this small n represent the outcomes in the combination form that we will choose from the large capital N. So C combination, N that is total number of experimental outcomes, and N is actually the group of outcomes, the combination of outcomes. So what is the formulation? N factorial. This is the sign of factorial. N factorial whole divided by small n factorial multiplied by n minus n whole factorial. This formula we will use to determine the total number of experimental outcomes of an experiment in combinations form, in group of items form, where C and n represent the combinations of n experimental outcomes from the large set of n objects. I am again repeating that this C and n represent the combinations of n outcomes from the large set of n outcomes. So what this n factorial represent? This is the expansion formula for the n factorial. We can write this n factorial like this. N factorial is equal to n multiplied by n minus 1 whole multiplied by n minus 2 whole multiplied by n minus 3 dot 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 until and unless we reach to the 3, 2 and finally 1 or even 0. So in the same way we can expand the small n factorial as well. N whole multiplied by n minus 1 whole multiplied by n minus 2 whole multiplied by n minus 3 and dot dot to 1, where 1 factorial always equal to 1 and 0 factorial also always equal to 1. Keep in mind that 1 factorial is equal to 1 and 0 factorial also equal to 1. So counting rule for combination is this formula, and this formula or this combinations rule we are used to determine the total number of experimental outcomes of the large n data set in small n combinations form. We are representing the number of experimental outcomes in group of items form from the large set of experimental outcomes. Let me clarify by putting one example. For example, a food inspector is inspecting 5 different food items like A, B, C, D and E. Determine the number of combinations of the any 2 experimental outcomes that inspector want to examine. So in example, this is very clear that food inspector is inspecting 5 different food items, 5 objects, 5 products, 5 food items. He is examining these 5 food items by choosing any 2 from the 5. So the large data set n carry 5 food items and food inspector is choosing only 2, which is a small n. So it's mean out of the 5 food items, food inspector is choosing only 2, any 2. So the question is this: they determine that when food inspector is inspecting 5 food items by examining only 2, so determine that how much experimental outcomes in the combination of 2 items of this experiment are possible. Experiment is what? Examining or checking 5 food items, but inspector is taking only a sample of the 5 items, only 2. So any 2 inspector want to inspect. So when any 2 means how many combinations of the 5 items are possible. When food inspector is inspecting only 2, means the combination of 2 items, how much experimental outcomes are possible? Answer: the total number of food items, total objects, total experimental outcomes are 5. Total experiments are 5, you can say. to examine food items, 5. So these are 5 experiments. And each experiment carry 2 outcomes, that the item will be defective or non-defective. So these are the 5 trials, 5-step experiments, and each step carry 2 outcomes, that food item is defective or non-defective. But food inspector is not examining all the 5 objects. Food inspector is choosing any 2. So the question is this: they determine that how much experimental outcomes are possible when food inspector is choosing any 2 from the large 5 data set. So n is 5 total objects, and small n, food inspector is checking only any 2 from these 5. So put n is equal to 5 and n is equal to 2 in this combination rule formulation we have. Cn over n, this is formula. We will just put for the capital N 5, for the small n 2, 5 factorial divided by small n 3 factorial, sorry, this is example. Here 5, n is 5, n is 2, capital N 5, small n 2, put n is equal to 5 and small n is equal to 2 in the formula we have. I am putting in here. So capital N 5, we replace for the n its value 5 factorial, whole divided by small n is 2, we replace for small n 2 in here 2 factorial, multiplied by again n is 5 minus small n is 2, whole multiplied by factorial. C52 is equal to combination of 2 items out of 5. What is the statement of this C52? The combinations, the total number of combinations of 2 items from the large set of objects, 5 items. So 5 factorial as it is, whole divided by 2 factorial, multiplied by 5 minus 2 whole factorial is equal to 3 factorial. Now C52 is equal to 5 factorial we will expand as we check the formula in the previous slide like this: n whole multiplied by n minus 1 multiplied by n minus 2 whole multiplied by n minus 3 and so on till 1. So here n is 5. So 5 whole multiplied by n minus 1 mean n is 5, 5 minus 1. Whole multiplied by 5 minus 2, whole multiplied by 5 minus 3, whole multiplied by 5 minus 4, and whole divided by this small 2 factorial. And now we will expand this 2, whole multiplied by 2 minus 1, and again this 3 factorial. So 3 whole multiplied by 3 minus 1, whole multiplied by 3 minus 2. Now C52 is equal to 5, 5 minus 1 4, 5 minus 2 3, 5 minus 3 2, 5 minus 4 1 divided by 2, 2 minus 1 1, and 3 as it is, 3 minus 1 2 and 3 minus 2 1. We just simply subtract the values, and C52 is equal to 5, 4, and this 3 2 1 cancel with this makhraj 3 2 1. So what is remaining in makhraj? 2 1. So 5 0 4 20 divided by 2, and 20 by 2 is equal to 10. What does this 10 means? This 10 means that if the food inspector will inspect the 5 different objects or 5 different food items by choosing the combination of any 2 items, so how much experimental outcomes are possible? 10 experimental outcomes of this experiment are possible. Means he can check A, B. Let me clarify in the next look. These are the 10 combination of 2 experimental outcomes. He can choose A, B, but he can choose A, C as well. He can choose A, D as well. He can choose A, E as well. He can choose B, C, can choose B, D, can choose B, E. How much experimental outcomes are possible when food inspector is inspecting any 2 food items? 10 combinations are possible, 10 outcomes are possible. Means he can choose first and second, first and third, second and third. He can choose any 2 items. So inspecting 5 food items by choosing the combination of any 2, how much possibilities, how much outcomes in combinations, how much outcomes in the combination of 2 items are possible? 10 outcomes are possible, as I write in here. A, B, A, C, A, D, A, E, B, C, B, D, B, E, C, D, C, E, D, E. These are all 10 combinations that are possible by choosing any 2 from the large set of objects, 5, from the large set of 5 objects. We can again repeat example. A food inspector is inspecting 5 different food items like these A, B, C, D, E. Determine the number of combination of any 3 experimental outcomes that inspector want to examine. Like for example, n is equal to 5 and now n is equal to 3. Small n, the combinations of any 3 items. So we will replace for the capital N its value 5 and for the small n its value 3 we have Cn is equal to n factorial whole divided by small n factorial whole multiplied by n minus n whole factorial. We will just substitute, replace the value of capital N and small n for the capital and small n in this formula. So 5 factorial divided by 3 factorial, 5 minus 3 whole factorial. C52 is equal to 5 factorial, 3 factorial, 5 minus 3 is equal to 2 factorial. C52 is equal to 5. This factorial I am expanding. 5 multiplied by 5 minus 1, 5 minus 2 multiplied by 5 minus 3, 5 minus 4 and divided by the 3 factorial 3 minus 1, 3 minus 2 and 2 factorial 2 zarab 2 minus 1. Now C52 is equal to 5 as it is, 5 minus 1 4, 5 minus 2 3, 5 minus 3 2, 5 minus 4 1 and whole divided by 3 as it is, 3 minus 1 2, 3 minus 2 1, 2 as it is and 2 minus 1 1. We will divide 3 2 1. This 3 2 1 cancel with these 3 2 1 and 5 4 divided by 2 1, 20 divided by 2. Again there are 10 number of combinations are possible when the food inspector is inspecting any 3 from the large set of 5 objects. मैं दोबारा ये एग्जांपल रहा दरी बेगम के फूड इंस्पेक्टर 5 फूड आइटम्स रहा एग्जामिन में कुना मुआयना में कुना चेक में कुना खू न में तना के हर आइटम रा चेक में कुना बहु जहू as 5 दो आइटम रा इंतखाब का क्यूरा एग्जामिन में कुना खू आले वो मेताना के हर दो के इम्कान दारा वो बायद एग्जामिन कुना को इंजा सवाल ये कि अगर वो as 5 group of items सिर्फ only 2 items दर combination form रख एग्जामिन या चेक में कुना को मालूम को क्या जी एक्सपेरिमेंट चीका दर एक्सपेरिमेंटल आउटकम्स इम्कान दारा दर combination 2 items ये फार्मूल मालूम मेशा इन टोटल फूड आइटम्स 5 अस औ चंद्र एग्जामिन या जज या चेक में कुना वो 2 आइटम्स रा चेक में कुना वो ये मालूम नहीं इसके कोदाम दो वो इम्कान दारा के हर दूरा इंतखाब कुना हो बई वजह मालूम को कि चंद कॉम्बिनेशंस इम्कानात दारा वक्त के फूड इंस्पेक्टर 2 आइटम्स रा इंतखाब में कुना को ये इन 5 और इन 2 बाय दरिए फार्मूल वजह शवा बजाय इन कैपिटल मा 5 आवर्दन और बजाय स्मॉल इन मा 2 आवर्दन वो 5 फैक्टोरियल तकसीम 2 फैक्टोरियल ज़रब 5 माइनस 2 होल फैक्टोरियल शुड आले C5 2 is equal to 5 factorial खुदिश तकसीम 2 factorial खुदिश 5 منفی 2 से factorial आले C5 2 बराबर ब 5 factorial बये फॉर्मूल बाज मेशा यानी 5 ज़रबे 5 5 منفی 1 ज़रबे 5 منفی 2 ज़रबे 5 منفی 3 ज़रबे 5 منفی 4 तकसीम 2 ये अजिंजा 2 फैक्टोरियल 2 और ज़रबे 2 منفی 1 अजिंजा ये से फैक्टोरियल से ज़रबे से منفی 1 ज़रबे से منفی 2 आले C5 2 बराबर ब 5 खुदिश 5 منفی 1 4 मेशा 5 منفی 2 से 5 منفی से 2 5 منفی 4 1 तकसीम 2 खुदिश 2 منفی 1 1 शुद से खुदिश से منفی 1 2 और से منفی 2 1 आली ये से 2 1 कतिये से 2 1 खलास मेशा 5 ज़रबे 4 तकसीम 2 ज़रबे 1 में माना 5 ज़रबे 4 20 तकसीम 2 मेशा और C5 2 दा बराबर ये वही माना कि अगर फूड इंस्पेक्टर 5 आइटम्स रा एग्जामिन या मुआयना में कुना चेक में कुना वो बैक वक्त आज 5 आइटम्स सिर्फ 2 गिरफ्त खो वो इम्कानात दारा ये एक्सपेरिमेंट टोटल दा नंबर ऑफ कॉम्बिनेशन 2 आइटम्स इम्कानात दारा कि हर 2 के वो इंस्पेक्टर में ख्वाह बाय पूरा एग्जामिन कुना हर 2 खो बई तरीका ये एक्सपेरिमेंट दा आउटकम्स दारा यानी दा कॉम्बिनेशन जोड़ में वो इन जवाज़े है 10 combinations of 2 experimental outcomes इम्कान दारा कि इंस्पेक्टर अवल और दोम ए बी रा एग्जामिन कुना को एम इम्कान दारा कि इंस्पेक्टर अवल और सेम ए सी रा ए अवलिनस और सी सेमस अजिंजा ए बिबिन ये सी सेमस ए अवलिनस ए इम्कान दारा कि वो अवल ए और सेम सी फूड आइटम रा एग्जामिन कुना या चेक कुना ये इम्कान दारा कि अवल ए या चारों डी रा एग्जामिन कुना एम इम्कान दारा कि अवल ए और पंजुम डी रा एग्जामिन कुना येम इम्कान दारा कि दोम बी और सेम सी रा एग्जामिन कुना येम इम्कान दारा कि दोम बी और चारों डी रा एग्जामिन या चेक में कुना यानी वक्त के इंस्पेक्टर में ख्वाह के any 2 items by check शवा एग्जामिन शवा हो ये एक्सपेरिमेंट दा आउटकम्स इम्कानात दारा कि दा कॉम्बिनेशंस अजीजूल मेशा